All right, this is problem number 3 on 8.3. I decided to start with it because number 1 was set up already nice and ready for you to go, and you could just start dividing. So I thought I would pick one that had a little bit more to it, and that way we get more bang for our buck here on the video. All right, so what we have is 6 minus 2x minus x squared over 2 minus x. I know this is division because I see that fraction bar. And remember, in algebra, a fraction bar is just the way we write division. We don't want to have that clunky old way of writing it. It makes it harder to work problems. So what we're going to do, first of all, if I'm going to do division, I have to have the bottom and the top, the numerator and the denominator, I have to have them in standard form, which means I want the biggest exponent first, then the next less one down, and then finally end up with the number on the end. So if I'm going to rewrite this, I'm going to say, okay, the biggest exponent is x squared, but it's a minus 1x squared, isn't it? So I'm going to put a minus. I could put the 1 there. I'm just going to leave it off because we normally don't write it. It would be a minus x squared. And then the term that would come down next would be something that has an x on it, just an x to the first power. Well, we've got this 2x, but it's a minus 2x. So I'll write minus 2x. And then it's a positive 6, so let me put a plus 6. Now, on the bottom, if I put that in order, that's a minus x. So that is the sign of the x. I need to keep that and just look at it as a negative x. So I have a negative x plus 2. Okay. Now, I look at this, and I could start dividing now, but if I do now, do you notice how both the numerator and the denominator start with a negative term? That's going to make my life a little harder. So what I'm going to do is get rid of it. So I'm going to put parentheses around this, and the top, and I'm going to put parentheses in the bottom, and I'm going to multiply by 1. If I multiply by 1, I don't change the value of the fraction, do I? It stays the same. And I can choose to write 1 any way I want to. So here's what I'm going to do. I'm going to write it as negative 1 over negative 1. That would reduce to 1. Why did I choose that? Well, if I multiply the bottom and the top by negative 1, I'm going to get rid of a bunch of those negatives that I see, especially those ones out front. Don't like the ones out front at all, okay? So let's do that. Let's multiply. When you multiply by negative 1, it doesn't change any of the numbers. It just changes the sign out in front of stuff, because let's watch and see that happen. And then again, you could do that a whole lot faster once you understand that. You could just zip through there and write the opposite sign on these terms. We'll go through the multiplication. Negative 1 times a negative x squared would give me a positive x squared. Negative 1 times a negative 2x, I'm distributing it to each term, would be a plus 2x. And a negative 1 times a positive 6 would be a minus 6. Now, in the denominator, I've got negative 1 times negative x. That's a positive x. And negative 1 times positive 2 would be a negative 2. All right, so this is what I'm going to divide. This is going to be a whole lot easier than if you look at what we have now compared to what we started with. This is going to be a lot easier to deal with. So let me write it down. I'm going to write down x squared. Remember, it's the top divided by the bottom. A lot of people still get confused about that, I know. And I don't know why I did that. What I meant to do was write it like this. It's x squared plus 2x minus 6 divided by x minus 2. I'm going to write the x minus 2 out here, okay? Let me just get rid of this. I'm going to just scratch it out since I can't really go back and erase it very easily. Okay, so this is what I'm going to divide. I'm going to kind of do each step in a different color so you can really follow along. First of all, I say, okay, when I do this division, I'm only going to look at one term at a time. So I'm just going to look at the first term, x squared. And when I divide, I'm only going to look at the x over here. Every time I'll just be saying how many times does x go into whatever I'm dividing into. Because we just are taking a little bite of it at a time. Okay, so I have x squared divided by x. Or x squared, take out an x, what would be left? There would be an x left. And just like we did in long division, whatever you get here, you multiply it by what's out front. So I'm going to say x times x is x squared, and x times negative 2 is a negative 2x. Now, if you remember in long division, what you do next is you subtract whatever you got here from what you started with. Okay? So let me put parentheses around that. And remember, I have to subtract each term, so it's like I'm distributing the subtraction sign. X squared minus x squared, those would cancel out. They'd be 0. 2x minus minus 2x would be a 4x. Okay, so I've got a 4x. Now, do you remember that when you did long division, what you did next was like bring the next digit down? Well, what we're going to do, and I'll write this in red, is bring the next term down. It's a minus 6. And now I'm going to say, I'm only going to look at this first part of it, the 4x, and I'm only going to look at the x out here with what I'm dividing. I'm going to say, how many times does this x out front go into 4x? Well, 4x, to take out an x, would leave you with a positive 4. So let's write that, positive 4 plus 4. All right, so 4 times x is 4x, and 4 times negative 2 is negative 8. And if you remember, what we do then is we subtract what we got from what we had. So what I'm going to do is put a minus in front, and I'm going to put this in parentheses because I've got to subtract each term. It's like I've got to distribute the subtraction sign. So you say 4x minus 4x, well that's 0, that cancels out. Then I have a negative 6 minus negative 8. That becomes negative 6 plus 8, doesn't it? And that's going to be a positive 2. So I have a 2 down here. Now I'm out of terms to drop down. I don't go do anything like I do in long division, like putting a decimal or anything. What I say is, well, how many times did x minus 2 go into x squared plus 2x minus 6? It went in x plus 4. Let me use green so you can see where I'm looking. It went in x plus 4 times, but it had a remainder of 2. So here's how I write that. I write x plus 4. It went in x plus 4 times, plus I had, do you remember how you could write remainder 2, or you could take what you got as your remainder, which is 2, and you could put it in a fraction over what you divided by this x minus 2? Well, that's what we're going to do here. This is our answer right here. So we take our remainder and we put it over what we divided by. So it's 2 over x minus 2. That's all there is to this. If you remember long division from elementary school, which hopefully you do, then that's going to help this make this a lot easier. All right, I picked number 17 because there was something missing here and that we need to know that we need to put in. When I look at this, I go, oh, look, they put it from biggest exponent down to smallest exponent in the numerator and the denominator. Yay, they weren't like messing with me, mixing the terms up. But let's look at those exponents. On the top, you start off with a 4, good. Then you go down to a 3. Uh-oh, look, there's a square. There's not a 2 term, a u squared term. So what I'm going to have to do is add that in. And what I'm going to do, I left some space for myself, but I put it in the wrong spot. I'm going to add in the u squared term, and that's going to be 0 u squared. There aren't any u squares, so that's 0 u squared. And then I'll look, so I've got to put that in there, otherwise my division is going to get really messed up, okay? And by the way, in the next section, we're going to do some division of a different type, and you've got to do that there also. You always need to write any missing terms in with a 0 in front of them. Okay, so I have 4, 3, 2. This 4u is really a 4u to the 1, so it's all there. And then I have the number. And really, constants, that's really 4u to the 0. U to the 0 is 1, so 4 times 1 is 4. So that's why they really are in order of descending exponents here. If you look at the bottom, everything's good there. You got a 2. There's an invisible 1 on that u. I know that doesn't look much like a u, but I'll try to help it there a little bit. And then we got the constant term, which is really u to the 0. We just don't write it down since it's 1. So now I'm going to divide this out. So I'm going to take and write this as a division problem. And I'm going to have trouble, I know, getting this on the paper. So I'm going to start over here. And I don't think I can fit it there. We'll see. We'll go over here, okay? So it's 9. I already have messed up. Got to leave myself space. It's 3u squared plus 2u plus 2 divided into 9u to the 4th plus 6u cubed plus 0u squared, got to get it in the right order, plus 4u plus 4. Okay. Again, make sure you're writing it down where you can read it on your paper, and then you're trying. That's supposed to be a plus there, and it looks like a 14 now. Let me put a plus there. All right, so just like I did on problem number 3, what I'm going to do is I'm only going to take one term at a time inside, and I'm only going to divide by the first term on the outside. So if I have 9u to the 4th, and I divide out 3u squared, 9 divided by 3 is 3. I had u to the 4th, but I took out u squared. That leaves me with u squared, okay? So now what I have to do is multiply that by each of the numbers that's out here out front. So 3u squared times 3u squared would be 9u to the 4th. 3u squared times 2u would be 6u cubed. 3u squared times 2 would be 6u squared. That's why I needed that 0 in there. I'm going to have to subtract that. All right, so we're going to subtract, and we're going to write our answer down here. When I write the answer, I'm going to change colors this time just so we can really see where our new problem is. 9u to the fourth minus 9u to the fourth, that's 0. That cancels out. 6u cubed minus 6u cubed, remember I got to put that subtraction sign with every term on the inside. That also adds up to 0, okay? So now I have 0u squared minus 6u squared. That's going to be minus 6u squared. All right, so this is what I'm going to start with now. To do my next division, I'm going to drop down the next term, which is the 4u. So let me drop down this 4u here. Draw that line all the way over, though. So now I'm looking at 6u squared, and I'm saying how many times does 3u squared go into 6u squared? Let's do the number first. Negative 6 divided by 3 would be negative 2. I'm going to write that right above the u squared term since that's what I'm dividing now. And sometimes it helps to help you kind of keep up with where you are if you'll do that. So negative 2 times negative 3 is negative 6, and then there's a u squared. Negative 2 times positive 2u would be a negative 4u. And then negative 2 times positive 2 would be a negative 4. Let's see, is that right? Yep. All right, so I'm going to draw my line. Now, I can tell what I really need to do is drop down this 4 also. Since I have a 4 here, I'll go ahead and drop down the 4. Okay? I know that's a little weird, but sometimes you do that when you see that you ended up with a term and the term that matches it is still up there on the top. We're going to drop that down. And what I'm supposed to do is I'm supposed to subtract this from what's on top. Okay, so here we go. I'm going to write my answer in green just so I can kind of see where we are. Negative 6u squared minus minus 6u squared. A minus becomes a plus. So it's really negative 6u squared plus 6u squared. That adds up to 0. If you're having trouble with that, you might want to go off to the side to do some of those calculations. 4u minus minus 4u becomes 4u plus 4u. Well, 4u plus 4u is actually 8u, and a lot of people are going to put 0 there just because they think, oh, good, it'll cancel out too, but it doesn't. And then 4 minus minus 4 is 4 plus 4, which is positive 8. All right, so I have 8u plus 8. Now, let's see. Maybe you think you're supposed to go divide again. Let's say that you thought that. Let's go look. Can you divide 3u squared into 8u? If I have 8u, can I divide out 3u squared from it? No, I don't have enough u's to take out. So really you're looking at the u. You can't take a u squared out of a u. So I'm actually done. And what I'm going to do is say, okay, this is my remainder, since the exponent on it is smaller than the exponent I was dividing by. So I can come up here and say, well, that's plus, the remainder was 8u plus 8, and I was dividing by 3u squared plus 2u plus 2. And that would be how you would write your answer. And I'll write it down here just so you can see. It's 3u squared minus 2 plus 8u plus 8 over 3u squared plus 2u plus 2. Sometimes in math you study something called a partial fraction, and a partial fraction has something to do with this remainder here on the end. Also, this is something that could come up if you were looking for asymptotes. In equation, maybe I have a function that looks like this, and I'm trying to find asymptotes. When that happens, sometimes I'll do what I just did here in number 17, and I'll find that I have an asymptote. I'll be able to find my asymptote from this answer that we got here. I'm not going to go into that right now. I'm just going to say we are done with that one.